Okay, this video lesson comes from Chapter 7 in Go Math, and it's Lesson 7.9, in which you're looking at identifying equivalent expressions. Now, the other day we looked at different types of mathematical properties. We learned about the commutative property, associative property, distributive property, as well as the identity property. And those properties oftentimes help us generate equivalent expressions. So if you need that insert or your notes on the different expressions, it might be helpful to have it out. Okay, the essential question reads, how can you identify equivalent algebraic expressions? Let me just annotate that for a moment. And the unlock the problem reads, each train on a roller coaster has 10 cars, and each car can hold 4 riders. The expression 10t times 4 can be used to find the greatest number of riders when there are t trains on the track. Is this expression equivalent to 14t? Use the properties of operations to support your answer. So we've got some things that we want to annotate for sure. We know that 10t plus 4 is the expression that's being used. Let me see if I could view this a little larger. Okay, in any case, 10t times 4 can be used to find the greatest numbers of the riders when there are t trains on the track. Is this expression equivalent to 14t? Okay, so we want to know, is it equivalent to 14t? Well, we need to determine whether 10t times 4 is equivalent. And what does this box say? It says one property of operations that you can use to write an expression equivalent to 10t. So we want to know what is one that we could use. Well, could we use the identity property? No, because it doesn't say anything multiplied by 1, or in the identity property of 0 addition, it's added to 0. What about the distributive property? Do 10 and 4 share any factors in common? No, so I don't want to factor those out. Are there 3 numbers that we're grouping with parentheses? Yeah, no, so the associative property isn't an option, but the commutative property, and it's the commutative property of what operation? Multiplication. Is definitely an answer. So what we want to do now is determine whether or not 10t times 4 is equivalent to 14t. And we know that the expression of 14t is the product of a number and a variable. So we could rewrite it using that commutative property of multiplication right there. And so now when we rewrite it, we just switch the orders and make this 4 times 10t. So we use that commutative property. And now what about using the associative property now, where we now take out this 4 and this 10 times t. And so what's 4 times 10? 4 times 10, doesn't that give me 40? And so that's 40t. So now when we compare it to what we had up here, which was 14t, and is that equivalent? No, but let's check just by using the values of a number that we can substitute in for t. So we can compare 40t and 14t, and we know that if we look at t as being 2, let's just test it out. 40 times 2 gives us 80. And if t is 2 on this side, 14 times 2 gives us 28. So these two expressions are not equivalent. Now let's just take a look and slow it down what we did. So the first thing we did was kind of go through our properties, and we have an insert in that, so we should really be able to identify, okay, when we have this expression right here, 10t times 4, can we go through and say, does the identity property apply? Does the distributive property apply? Does the associative property apply? And we determined that the commutative property could be used. So we rewrote it. Then we did actually use the associative property when we looked at grouping now. If we have 10t times 4, so now we can look at 4 times 10 and then have that t on the outside, and we know that that equals 40t. And what we came down to is realizing that 40t and 14t are not equivalent. Let's take a look at the next example on the next page. It says use the properties of operations to determine whether these expressions are equivalent. And we've got two different expressions here. I'm going to highlight one in yellow, highlight the other in blue. The expressions 10y plus x is the sum of two terms. So we want to be able to rewrite this 7y plus x plus 3y instead as the sum of two terms. All right, how can we do that? We can do that by first saying, let's combine all the like terms we have. Don't we have terms that are alike? We do. The 3y and the 7y are like terms. Now, here they want us to use the commutative property of addition to rewrite the x plus 3y. And so that's no problem. The x plus 3y can end up being 3y plus x instead. And now when we look at it, we can say 7y is what's missing plus 3y if we end up using, let's say, the associative property of addition, and we're combining those like terms to then give us what's 7 plus 3? 10y. 10y plus x. So some of these problems you can just simply look at, let's combine the like terms. If we combine the like terms, will it then give me an equivalent expression to the second expression that's sitting there? And in other cases, we may have to go a little further and dig a little deeper. So did we determine that 7y plus x plus 3y and 10y plus x are equivalent? We did. They are, in fact, equivalent. How do we do that? Well, we looked at rewriting using the commutative property of addition, and in the commutative property it says I can switch the order of these addition values and it doesn't make a difference. The answer is still going to be, or the expressions are going to be equal. Then here I went and used the order of or the associative property, and we grouped them together so that we just had the same like terms within the parentheses, which made it easier to combine. You have the same like terms here as well, so I think that that's just as easy to combine and to see. Let's look at B, which is going to be one of the last examples, and we have 10 and in parentheses m plus n and 10m plus n. So the expression 10m plus n is the sum of two terms. So rewrite 10m in parentheses plus n as a sum of two terms. Okay, no problem. We could use the distributive property for this one. And in this case, because the distributive property says you get a 10m, and guess what? N, you also get a 10. It's just going to be written as 10m. Let me make this blue like I had. Plus 10n. That's supposed to be gray. All right. And so when we look at it, we can say we can multiply within those parentheses, and that gives us 10m plus 10n. And so now we're comparing the expressions. Because remember, look what we did. We used distributive property to kind of factor these two out. And we want to look at whether 10m plus 10n is equivalent to this expression right here. That's the expression we want to determine if it's equivalent. This pen is a little too thick. Okay, well, think. The first terms in the expression are both the same, and they are. But the second terms are different. And that's important because take a look. This is 10m plus an n. What doesn't it have? It doesn't have the 10. Now we can check it once again by substituting values for m and substituting a value for n. So let's just look at choosing a value for m and n. We want to choose 2 for m and 4 for n. So let's just put the 2 here and the 4 here. And so this is going to be 2. This is going to be 4. What's 10 times 2? 20. What's 10 times 4? 40. What's 20 plus 40? 60. Remember we said m was going to be 2, n was going to be 4. And so let's go ahead and substitute 10 times 2. And this was, remember, plus 4. So 10 times 2 is 20. And then we just have the 4 here. And the 20 plus 4 gives us 24. So clearly those expressions are not equivalent. Now, I know that's a long process to kind of check to see if expressions are equivalent, but let's just really think about sometimes using logical reasoning. If I simply use the distributive property and on a very simple level, just simply factor this out, here is what I get. Because you get a 10m and you get a 10m. And that to me looks very different, not very different, but slightly different than 10m plus n. Throughout the course of this particular lesson, you're going to be asked to identify if expressions are equivalent. In some cases, you're going to be asked to write equivalent or not equivalent. Please exhaust all the properties of operations to determine whether they're equivalent or not. And with your share and show today, remember you're getting a slip of paper that you're writing it on.